Hey, what's up, guys? I'm the representative. Today, we starting test revision now. Very sneaky in the test revision. First, we start with static electricity. This is the fundamental concept for electricity. You have to understand this, So basically, what static electricity is basically around charge. I mean, the whole electricity course is about charge. What is charge? The subatomic particles, we have neutrons, which is neutral, it doesn't have any charge, and then proton, which is positively charged, and electron, which is negatively charged. And actually, proton is fixed in the nucleus, and it's very chunky and heavy. It's about 1,800 times heavier than the electron. So it's lazy and it's limited in the nucleus, so it doesn't move. What moves is the electrons out of the shell in the electron cloud. That's what moves. And then normally, say that's a helium, and it has 2 electrons, and then you get rid of one. It actually has 2 protons, my bad. And you get rid of one, you're only left with 1. And then 2 positive, 1 negative, positive more than negative. Overall, this ion becomes positively charged. But think about this, if you add another extra electron onto the helium atom, its negative charge is more than the positive charge, which means the overall charge it has, it's negative. And then when they meet, this one has 1 extra, this one lost 1, wants to gain 1, wants to lose 1. They meet, I'm gonna lose 1. Okay, I'm gonna receive 1. Sneaky. This electron flows from this ion to this ion, and then they become neutral because 2, 2, 2, 2, no charge. But during this process, the electron is moved. This is called current. The move of electron, the move of electron is called current. But actually, the current flows from the negative end of the DC battery to the positive end. But a stinky guy called Benjamin Franklin said it flows from the positive to the negative. And then because she's so authorized, people was like, okay, positive to negative, I'm gonna follow this theory. Follow the theory. It was stinky wrong. And then decades later, people figure out, Benjamin Franklin is actually wrong. And then they discover it's actually from the negative to positive, because it's electron, bro. It's electron. Positive end has more electrons and negative end has less electrons. So it's like this, not like this. It doesn't make sense, doesn't it? So instead of just saying Benjamin Franklin is wrong, why don't we just change the definition of current? And then now they have conventional current. They change the definition of current from the flow of electron to the flow of positive charge. Positive charge. Be careful with this. So they meet Benjamin Franklin theory. What a dumbass. So Shiba, isn't it? Static electricity can be generated by friction and induction, you know. In this case, I'm talking about electrostatic induction, not electromagnetic induction. It's a different thing. It's electromagnetic induction is much more complex. Basically, what this means is, let me just get a drink real quick. Basically, what this means is you have a charged material. Let's say in this case it's positively charged. What does it mean by positively charged? Proton can't move. You can't add more protons in because otherwise the atom is going to change. The atom changes, it's going to be a different element. I mean, it's different element. The proton can't be added. So the only thing that moves is the electrons in the electron cloud. This actually just means it has less electrons compared with protons, so its electrons are lost. It's positively charged. And we have the material, which is neutral. That means it doesn't have any charge. Its electron number and proton number are equal. And then, say this is a metal. If you take chemistry, you will know that metal has a lot of free electrons on the outer shell, because its outer shell electron number is mostly below 4, which means it wants to lose it in order to make a stable outer shell. That means all of the electrons are attracted by this positive charge. So electron attracted. Electron is actually just negative charge, isn't it? And then from that side, these atoms lost electrons, so the proton numbers are greater than the electron number. So they are positively charged because their electrons are lost. So their electron number is smaller than proton number, positive more than negative. So the overall is positive. What is this? It is actually inducted with one terminal with negative, one terminal with positive, similar to a battery, isn't it? But as long as you remove this stinky charge, no more force acting on it. Oh, force, I forgot to talk about this. My bad. Basically, it has a force, these electrons have a force moving toward the charge. And then this is the repel force, the different direction. As long as you remove this charge, this whole metal becomes neutral again. Yeah, that's how it works. Because these positive and negative attract each other, because like charges repel, different charges attract the different charges, so they attract each other, and then they become neutral. So no more charge. That is called electrostatic induction. It is completely different from electromagnetic induction, okay? Electromagnetic induction states the relationship between magnetic energy and electricity energy. They can be transferred like This can be done by a coil and a permanent magnet. But we're not going to talk about this. We're going to talk about this in year 12, okay? Hiba. And then, if you're in Mr. P's class, you'll be using the Van de Graaff generator. It's basically a stinky belt with some metal brushes, a little brush like a metal toothbrush, but this is a belt brush, you know, 一细胞. This is like a pin thing. It's a very thick pin. It shouldn't be that thick, but I'm just bad at drawing, so take it. And then you have the little metal dome thing that you can electrocute yourself. Basically, this is a motor, and then as the motor spins, the belt spins as well, because the belt has a pretty small electronegativity. Remember electronegativity? It states how much the atom wants to attract electrons toward it, or how much does this atom want to grab the electron to him. If it's small, it doesn't want to grab electrons because it's less greedy, you know. So they give out their electrons. And metals, electronegativity is relatively higher. So aluminium is about 1.7 if I'm not wrong. I might be wrong, but it's definitely greater than rubber. And you're gonna know sharp things, you know. If you have a structure, like an object with this structure with a little pin on it, charges will mostly stay in this little pin. So these charges are all transferred to this little pin and then spread it to the whole dome. That's basically what happens. And then this, from friction, the electrons from the belt flows to the metal dome, which makes the metal dome negatively charged. And since the electrons are lost in the rubber belt, its proton number is actually greater than its electron number, so it's positively charged. And then these negative charges just stays on the dome, and then if you are touching the ground, I mean, this is JJ Roshma, quite stinky, isn't he? Touches it, and then he's grounded. Ground? Why is ground neutral? Have you ever think about this question? Let me tell you, because ground is very chunky, it's very big, you know. It is so big, it's literally the entire Earth. So it can store a lot of charges, and all of the charges are spread to everywhere. So it tends to be a very, very small charge on each part, you know. So that means the overall can be considered as neutral everywhere, basically. And then what you will know, charges will exert force on objects with different charge comparative or it's neutral. So in this case, it's negative charge on the metal dome. So if JJ is positively charged, the negative electron, negative charge from the metal dome will actually just flow to JJ into the ground. But JJ is normally not charged. JJ is mostly neutral. The ground is neutral, and the electrons also flow to neutral stuff. That's current. Current running through the body, getting electrocuted, and then JJ will be like, That's what JJ's can react exactly. Although I'm not in his class, I know what his reaction is because he's quite stinky, you know. It's basically a Van de Graaff generator. And that's pretty much everything for today. No, we haven't talked about potential difference yet. Oh no, I'm gonna talk about it next lesson. Sorry guys.